I'm not that surprised that the human programmer actually won.
Human coder beats OpenAI in a marathon programming contest. Polish programmer Przemysław Dybiak narrowly defeated OpenAI's advanced AI model in a 10-hour coding marathon at the @Coder World Tour. 1.8 trillion points compared to AI's 1.6 trillion. The @Coder World Tour Finals 2025 took place in Tokyo, Japan as an international on-site programming competition featuring the platform's top 12 performers from the 2024 ranking system. 10-hour heuristic contest on July 16th where competitors tackled an NP-hard optimization problem and a 5-hour algorithm contest.
I'm not that surprised that the human programmer actually won.
But it's still very interesting that in aspects like even this, in a 10-hour where something like AI you would assume that can win because it's 10 hours of coding.
Yeah.
And AI doesn't get tired. It's just, more forest to be burned.
The thing with LLMs these days, LLMs are really good at replicating what they learned. I mean, they are literally just statistical models which predict the next token, very simplified. And the thing generally is with now this maze issue is the LLM may basically know, okay, I have these algorithms for pathfinding, I can apply this and this, but it doesn't know the optimal way to combine multiple algorithms together, like chain them together, or how to optimize for a specific problem with a specific range. My assumption is that the LLM quickly had a solution working, quickly iterated on it, but to get to the best solution, it would basically need like much more time, many more, let's say, execution branches to play around. I don't know if they used here a single instance which did all the things, if they had multiple instances running concurrently, testing all possible solutions. But basically, in a smaller scale, I expected, to be honest, OpenAI to win. That they did not win is also understandable, though. But what I can tell you this, though. If this competition would not be in 10 hours, but let's say a much more complex problem and would be over, let's say, a week or month, the AI would have definitely lost.
Yeah.
I no doubt.
So is this context that is so huge that we still can do this like small level, but also very abstract and very huge computing?
In my ideal scenario, I would imagine that if, let's say, an LLM executes, let's say, a program, it would compute after each line what the state of the program could be in a range of things, similarly to how, for example, TypeScript union types work.
Yeah.
And I could imagine if the LLM, for example, use such a system and narrow it down, it could actually get to an optimal solution. But right now, the way the models are, they can test the code, they can just write it, but they mostly like test and like they imitate it, but they don't have an actual state with each line of code. And I think that's one of the big issues we have right now, especially, let's say, if you work in a large code base and you have an LLM, it puts some random functions, it puts some random data, because the LLM actually does not evaluate the LSP, the data. It's just like, it just makes stuff up and just those assumptions. And we need to, AI generally needs to work more like, we give you information and these are the information, this is the truth, and you can only work with this truth, and that's like still lacking.
I think it's very interesting with some models, like they have tool calls, so they can search the internet, for example, to look up something, and they say they do, but they actually end up not doing it. So
Gemini had that issue severely, where basically it says, hey, I should use this tool call, but it does not because it was not properly trained in. But now we have new models like Cmd+AI and Grok, which have it properly trained in and are much more eager to call it. TheoGG, a different YouTuber, as an example, he also ran tool testing with Cmd+AI, and he did not run into a single issue on his benchmark. So if that is true, then Cmd+AI is even more reliable with tool calling than cloud code. And tool calling is literally the A and O to work on agentic workflows and, let's say, data as coding assistants.
Everybody talks about tool calling. What is tool calling?
We give the AI a couple of doors. Each door has a description on what it does, and the AI can decide to go through the door and trigger something. It's like basically a list of functions or a list of APIs, and the AI can use these APIs in his messages. You have an agent and you ask it about the weather, and then in its tool call list, it has a weather tool, and then you can just say, it basically you define like this short description what this tool does. Let's say it gives you the current weather, and then you describe what kind of information it needs, like city and street. Then the AI could ask you, hey, I need it for this city and the street, and then it's basically just an API call, and then we get a response back, and that response is then incorporated into the next message. So the AI has a first message where it says where it, let's say, thinks internally, tells me which tool calls it needs, and then a second message it responds to the user.
Yeah, okay, that makes sense.
This is part of a larger conversation on my show, Cmd+AI, which we stream live every single week. We discuss the news and all things related to AI in the world of design and web. Catch us next week and join in the banter.